Hi everybody, today we are continuing with factored form and specifically how it can be used to answer questions. So when you go into problem solving with quadratics, it's important to recognize if you are given the equation, what form you are given the equation in. On the test, assignments, exam, you might be given an equation in vertex form, which is useful because it shows you the vertex. Or you might be given an equation in factored form, which is useful because it shows you the x-intercepts, or at least you can find them with very minimal work. Okay, so questions that are useful for factored form is anytime the dependent variable is zero. So basically, anytime you are hitting these x-intercepts. So in this case, y is always equal to 0 or h or whatever it may be. So if you have something that is height versus time, then that would be when something hits the ground, when the height is 0. Then you want the x-intercepts. Or if you have a dolphin leaping out of the water, when it splashes and hits that water level, that is, again, the x-intercepts or the zeros. All right, now you can also use the zeros to find out how wide a parabola is on the x-axis, and you can use them to find the equation in factored form. So we're starting with this example, which gives us a gate, so it's kind of like an archway. It's 20 meters tall, so that will be helpful for the vertex, and it's 22 meters wide. So in this question, they want the left base to be located 4 units to the left. So here at -4, 0. And since we know it's 22 meters wide, we need to count, 22 units. So that would be 4 here, so there'd be 18 left, which would get us to here. So our other x-intercept is 18. Now, we need the vertex. The vertex is going to occur halfway between these two x-intercepts. So -4 plus 18 is 14, divided by 2 is 7. So 1, 2, 3, 4, 5, 6, 7, and then we're going up 20. So let's go up by 2's here. So again, 1, 2, 3, 4, 5, 6, 7, right up to 20. So this vertex is 7, 20. Okay, and then we can draw our parabolic arch down. So you don't want the arch to look too straight. You don't want to curve out too much to look too L-like. So that is a good representation. So now we're going to come up with our factored form of the model. So we will start with, y equals a, and then we know our first 0 is -4. So we do x plus 4, remember minus -4, and then x minus 18. Now to find our a value, we will sub in our coordinate of 7, 20. So we'll put in 20 here and 7 for both of our x's, and we'll be good to go. So 20, I should have closed that. 20 equals a times 7 plus 4 times 7 minus 18. So 20 equals a times 11 times -11. So now we do this multiplication, which is -121. And we divide both sides by -121. So a is equal to 20 divided by -121. So we just bump the negative out front since it's negative. Now, this can also be written as -0.165. Again, it's a word problem, so often decimals are more useful. So I now would represent the variables. I would say let, we could say x represent distance from Okay, so basically we don't know why they chose like this axis, but that's what they chose. So we're going to just say from landmark, they must have some landmark as to why they did that in meters, and let h represent height of arch in meters. So h is equal to negative 0.165 bracket x plus 4 bracket x minus 18. Okay, so now let's continue to example 2. So in this case, they give you the formula. Sorry, the equation rather. And they ask you some questions about it, including a sketch. So this is the path of a jet plane in training, and it's the height above the ground after a certain amount of time in seconds. So what are the x-intercepts, or it should really say t-intercepts, to be honest. Do they both have meaning? If so, what do they mean in context? So to find our t-intercepts, we take our equation and we set it equal to 0. Okay, that is crucial. You're setting your dependent variable, in this case height, equal to 0. Now, a lot of people here are tempted to just say t equals negative 40 because they look at this last number and they just change the sign. But remember where they're coming from. This whole bracket, 2t plus 40, would have to equal 0 for this bracket to be 0, and therefore the product to be 0. So you get 2t equals negative 40, so t equals negative 20. It's not actually negative 40. So put a big star there. That is a mistake I see all the time. And in this case, again, t minus 100 equals 0, so t equals 100. So this is time. So these both would be seconds. So does negative 20 seconds make sense? No, it doesn't. So we say that this is inadmissible since time cannot be 0. So since time has to be greater than or equal to 0. So what do they mean in context? So the t-intercept that we care about is 100, 0. So remember, this 0 means that the height is 0, so it means that the plane must have landed. So the plane lands after 100 seconds, which could be seen as 1 minute, 40 seconds. Okay, at what time does the plane, that should say plane, reach its maximum height? So this is actually where this pretend 0, this pretend t-intercept is actually useful, and we actually need it. Even though it doesn't have meaning within the context, it is useful in helping us find the t value of the vertex since it occurs halfway between the zeros. So we take negative 20 plus 100 and divide it by 2. So again, even though it doesn't have meaning, doesn't mean it's not useful. So this is 80 divided by 2, which is 40. Okay, so at 40 seconds, they're reaching its maximum height. So to actually find that maximum height, we do h, we find h. So h is equal to negative 5, bracket 2 times 40 plus 40 and 40 minus 100. So we get negative 5. Okay, this is 80 plus 40, so 120. And then this is negative 60. So when you multiply, oh, I'm already on part C. Sorry, guys, this should be down here. So when you multiply that through, you get 36,000 meters. So therefore, we can say the max height is 36,000 meters. and it happens at 40 seconds into the flight. Okay, so now you can sketch a graph. So we know that finish at 100 meters. So I know I need to get all the way up to 100 seconds. So I'm going to go up by tens, 10, 20, 40, 60, 80, 100. So I know that that's when they land. And then I can put our minus 20 over there, even though it's not useful. You'll show how I represent that. You'll see. So we need to get up to 30,000. So I did my height in 6,000s. Sorry, 36,000. So this is 6, 12,000, and then 18, 24, 30, and 36. So this is my height in thousands. Okay, so my maximum occurs at 36,000. All right, now to help me with this, I'm going to find the h-intercept so I can have a better, because these 3 coordinates aren't really enough for me to have a really good view. So I'm going to set t equal to 0 in the equation. So you get h equals -5, 2 times 0 plus 40, and 0 minus 100. And if you put this through, you get 20,000 meters. So that means it was launched from 20,000 meters. So this is 18, so 20,000 is about here. And it also means I have symmetrical partner here at 80. Okay, this is 40 away from the center, so another 40 away. So basically I go up and then I come back down. If you want to represent this section, you can with a dotted line since it doesn't actually have any relevance. So this 0, 20, again, is so it was 20,000 when they started tracking or started. Then at 40, it's at 36,000. And at 100 seconds, you're at 0. So because I said the height was in thousands, you can just write, you should just write the 20, the 36, and the 0 since it's already in that form. So there you go, guys. That's how you can apply factored form to questions that involve real world contexts. So thanks for watching, and I hope you learned lots.